Hello, here is the question number 24, which says two identical perfectly conducting rings are coaxially placed very close, infinitesimally small separation to each other. Each of the coils has a inductance L and carries a current I naught in the same sense. How much minimum amount of work has to be done in making their separation infinitely large? So this is the initial arrangement when they are separated by large distance. So what will be the minimum amount of work done? Now at this situation, we have two coils, and if we can find the stored energy in the system this initially, and we can find the stored energy in the system finally, then we can think about how much the work done is as per the work energy theorem. Now let's first understand one formula. It says energy of a system consisting of two inductors L1 and L2 having currents I1 and I2 respectively, and M has as their mutual inductance, and that energy is given by this formula, which says U is equal to half L1 I1 square, that means self energy of the first coil, plus self energy of the another coil, that is half L2 I2 square, plus the energy of mutual interaction, that is M I1 I2. This can be separately proved, and this could be remembered as a formula for two conductors having mutual inductance as well as the self inductance. Now for this given system, you'll find the flux passing through a coil due to its own current will be equal to the flux passing through another coil due to current in one coil. That basically trying to say that entire flux is linked together. That means here mutual inductance and self-inductance will be identical. So for any system or for given system, we have M is equal to under root L1, L2. This L1 and L2 are equal to L, so M comes out to be equal to L. So for this system, mutual inductance is equal to self-inductance, and both the coils will have the self-inductance equal to L. Now, by using this formula, we can find out the initial energy of the system. So U initial is going to be half L I naught square plus half L I naught square plus M, which is L I naught. So it turned out to be like 2L I naught square. So this is the initial energy in the system. Now finally, these rings will be at infinite separation, so the mutual interaction or mutual inductance will be zero because there will be no flux linked together. So M term will become zero. So we need to find the individual energies, that is self energies. So you'll find in order to find these self energy or the energy due to self inductance, finally we need to know how much the current is flowing. Initially they had current I naught. So should we consider the same current later on, or should we find out some other way, or we should think about how the current is going to behave? So since they are perfectly conducting rings, so there will not be any resistance on them. So there will be nothing to change the flux. Right? So we will say flux of these rings should not change. Or we can think in this way that since these rings are perfectly conducting, so there will be zero EMF. Why there will be zero EMF? Because there will be no potential difference because of any other thing. So we consider equivalent circuit, LR circuit. So potential difference across the resistance, because there's no resistance, so you'll find potential difference across this inductor will be zero. And if the EMF is zero, that means this EMF is d phi by dt. That means flux does not change. So this is the crux that we need to carry forward. So flux, if the flux is not changing, so we need to find how much the flux one coil has initially, the same flux it will have later on too. Initial flux is equal to final flux. Initial flux in one coil will be because of its self-inductance, that is L I naught. Another will be because of another coil, so that's because of mutual inductance, that is M, the mutual inductance, and the current in the second coil. And this turn out to be equal to finally current IF, and there will be no mutual inductance later on, so there will be self-inductance L. Now we know this M is equal to L, so that is 2L I naught, and which is equal to LIF. From here we find IF, which is current finally in each coil, which came out to be 2 I naught. Now finally stored energy in the system will be U finally. In one coil you will find half L IF square and another the same amount. IF is equal to 2 I naught, so we can say this is going to be like L 2 I naught square, which come out to be 4 L I naught square. So this will be the energy in the two coils later on. This was the energy in the two coils initially. Now you find stored energy has gone up. So work energy theorem will say work done is equal to increase in the potential energy. Since we are not considering any motion of these rings later on, that means we are considering kinetic energy to be zero, or change in kinetic energy to be zero. Therefore this work done is going to be minimum, and then this delta U come out to be U final minus U initial, which is 4L I naught square minus 2L I naught square, which turn out to be 2L I naught square. Therefore the minimum work done in doing the recommended case in this question comes out to be 2L I naught square, and that becomes our final response. Thank you.